Alrighty, so here I'm part 3. So here's where we're actually going to put the stuff into practical action. So the big guiding question here is, how are congruency and similarity principles immediately applicable? Okay, immediately meaning that we're going to evolve this idea over time, but how is it applicable right now in this moment? Well, how it's going to be applicable is that we can basically apply algebraic principles using these geometric ideas of similarity and congruence. This comes in two varieties that you're going to see, like not just from me, but also like on standardized tests and stuff like that. And the two varieties are, hey, these two triangles are congruent or similar. I'm telling you that. I'm giving you that. Set up and solve an equation that solves for x or y based on that relationship. There's a slight variation of it, which is, hey, we don't know these are similar, but let's assume they're similar for a minute. Can you set up some equations to solve for the x and y values, even though we don't know it for sure? Now, the good news for you is that it doesn't really matter which one you use, because congruency implies equivalence, ratio means those proportions, those division problems. And in both cases, we're dealing with basic equations here. And so that's really going to be like the big thought process. Like if this was me trying to boil this down into a bunch of steps, the first thing I'd have to do is establish congruency or similarity. Okay. 2, I would figure out the corresponding parts. Now this may actually you'd be making a corresponding parts list or just doing some careful marking on your diagram. And 3, then I would set up and solve equations. Okay, in setting up to solving the equations, that's going to tap into your algebra skill set, and so hopefully this is going to land in a very comfortable place for everybody. But the best thing we can do is just kind of jump into a couple examples, so let's get to it. So the first question, given that the triangles are congruent, use a congruency statement and find the values of x and y. And so let's establish first thing, our congruency statement is actually right here. That's a really important part of this. We can't always assume the triangles are going to be congruent or that they're going to kind of fit and correspond the way we expect them to. So having a congruency statement, it becomes super important. This might be the variety where we're just going to do some marking. And so we have to make some observations right at the bat. We kind of have to notice what we have on our triangle, especially in relationship to the variables. And so we have DE here, and we can notice DE is listed first. And so that means it corresponds directly with QR, and we should actually mark that too. QR is right here. Okay, so QR and DE are corresponding. We're told the triangles are congruent, and so we can conclude directly that DE has to be congruent to QR. Now the reason why the observation is important is because we're told what those values actually are. We're told that DE is 5y minus 7 feet, and we know the corresponding value on the other triangle is 38 feet. Now if we have congruent pieces, that means we have equivalent expressions. Namely, we can tell that 5y minus 7 has to be the same as the one on this side, which is 38. Okay? And so this statement here comes from the congruency statement, that because we have substitution. And now we can just let our natural algebra skills take over, and we can solve this guy out. Now, in terms of solving it, we're just trying to get y by itself. And so I would start by adding, no, not 8. What am I doing? Adding 7. Leaving us with 5y equaling, what's that, 45. And then, of course, dividing by 5 in both cases, just like you did it 500,000 million times in algebra last year. The 5 is canceled to a value of 1, so y has to equal 9, because 9 times 5 is 45. Okay? Now we should take a minute and test this, because we just shouldn't accept that outright. We should do a quick check step. And so we can take our original DE, since we know what QR is, we can take our DE, which is 5y minus 7, and we can substitute in the value of 9, and see if this actually works out to be 38, because that's the value we're trying to hit. And so 5 times 9 is 45. We subtract 7, that's going to equal 38, and so we know that we're actually correct. And so y equals 9 is what we're looking for. This is just us checking our work, because, well, that's what you should do. Okay, now we're not done, because we have an x value. Now the x value is actually going to be this angle, which is the angle S. And so going to our congruency statement, S is listed last, and so it should be corresponding and congruent to what's listed at F. Now, this is weird because F isn't actually listed. Like, this is what we're looking for. We need this angle, but nothing is there. No reason to despair. This is an easy problem to overcome and fix if you know a little something about triangles. And the thing about triangles, sorry, I had to step away and grab something really quick. The thing we should know about triangles is that all the angles are fixed to a particular total. So if you don't know what total I'm talking about, think about this. If you add all the angles of a triangle together, what number, what degree value will you actually get? And so pause for a second, consider that question, and hopefully you came up with the answer of 180 degrees. And so, if we take 180 degrees, we subtract off the 123, we subtract off the 29, we're left with this value being 28. Okay. And so knowing that these triangles are congruent and those are corresponding, we can then conclude that angle F has to be congruent to angle S. And so this is us figuring out those corresponding parts. Now in terms of substitution, angle F is actually 28 degrees, angle S is 2x plus 2 degrees. We know they're equivalent, they're equal because the triangles are congruent. So congruency gives us equality, and now we can just solve algebraically speaking. So we can subtract 2 on both sides, so that'll give us 26 is the same as 2x. We can divide by 2 to get rid of that multiplication of 2, leaving us x to be 13, not degrees, excuse me, just a value of 13. Now we should test it again because we know 28 is the total that we have to hit. If we bring in the 2x plus 2 expression, substitute the 13 for the x, 2 times 13 is 26, plus 2 gives us 28, and so we know that we hit the total because both angles are 28. Okay, and so in quick review, you have to notice if it's similarity or congruency. In this case, it's congruency because we have a congruency statement. We then have to figure out the corresponding part, which we can use the congruency statement to do that. And then we have to set up and solve equations based on that. Okay? And so in our example number 2, we're going to explore maybe a different thing. This is going to be similarity. We know it's similarity 1 because, well, frankly, it tells us right here. So like this right here, the similarity statement that I'm making blink, that tilde is a symbol for similarity. But also we can look at the triangles, and this is definitely not congruency. One is definitely bigger than the other. Okay? And so we're going to approach this in a very similar way. We have to find the corresponding pieces and use our similarity statement to figure out what's what. The problem is going to be, I think, when we get to the side length stage, because, and this, you're going to make a mistake here if you're not paying close attention, these side lengths are not equal, therefore it's not going to just be a normal equation, but you'll see that in a sec. Let's deal with the angle first. I think that's going to be the easier of the two. So we have this angle at W, which we see is listed last. And so that should correspond to the angle at T, which is this guy right here. I'm getting that directly from my similarity statement. And so then I know that the angle at W, should be congruent to the angle at T, because in similarity, you do actually have congruent angles. So that makes negative 2y plus 50, which is a W angle, the same as the T angle, which is 3y. So again, this is basic equation solving. This is something that is an expectation for all of us that we can do with pretty much no problems. So if you have to review a little bit to make that happen, know that you have the skill, you just have to do the practice. So we subtract there and get 50. 3y and 2y make 5y. And so dividing it out by 5, we have y to be 10. Doing a quick check here, we have negative 2 times 10 plus 50. And we're checking that against 3y, which, I mean, 3y, I don't think we have to do anything special there. That's just going to be 30, right? And so we have negative 2 times 10 here, which is negative 20, plus 50 is 30, and that's going to be the same as 30 that we get for that angle, so we're good. So here's where it's going to get a little bit weird, but remember, this is similarity, so we don't have an equality here, an equal sign here, just a normal equation. We're going to actually have ratios, which means we have proportions. That's the other word associated here. But let's first figure out like how we're going to associate this. So we have this UV thing, this UV side, and UV is listed first. So we got to correspond that with US, and so US is this right here. Now we do have to write ratios, and so we're not going to like just set these equal to one another. If you do that, you're thinking congruency, and unfortunately you're wrong. What we have to do is set up a ratio, in other words, a k-factor calculation. If you go back to the previous set of notes, we did that. That's what this was all about. This was the ratios or proportions that I keep hinting about, and that's what we have to write here. So we have to establish a big to small in terms of order, and then we have to start filtering those into our equations. It doesn't really matter which is which, we just have to stay consistent. And so for this one, I'm going to take the small over the big, and when I say small and big, I do mean triangles. And so of the corresponding pieces, the small side is 18, the big one is 5x plus 11. Now the problem here is we don't have enough information to solve yet. We don't, because we only have a ratio 18 over 5x plus 11, and you can't solve that unless you put that into some kind of equation. But luckily, everything in a similar set of triangles follows the same k-factor. So what we could do is use some of the other numbers involved, namely this one right here, VW. And so VW is listed second, and so that has to correspond to ST, which is also listed second. So we have 24 and 88. Luckily, we have two more numbers. And so if we follow the same ratio, small triangle is 24, large triangle is 88, and so we do have a solvable proportion. And so this is something that we can solve because we do have an equal sign and we do have two numbers on either side. Now we can be sure that these are equal because in similar triangles the k-factor is the same for all three sides, ergo the ratio should be the same as for all three sides. And so once we have this established, this is just literally an issue of solving the algebra once again. Okay, and so here we have many techniques. We talked about this not too long ago in class. So I think I'm just going to use a cross multiplication technique because I think that's the fastest to reduce this. And so I'll take 18 times 88 and I'll write the result. So I have a calculator here. 18 times 88 is going to be 1,584. And we'll just cross it up the other way. So 24 times a quantity, and we should put parentheses around that. So we have 24 times a quantity, 5x plus 11. And those are going to be equal because, well, we're reducing the fraction into now a nice linear equation. We should distribute this left-hand side, so 24 times 5 should be 120, and of course the x's come along. And then we have 24 times 12, no, I'm sorry, times 11, and that's going to be 264 positive, and that's going to be 1584. Now we just go about the business of solving algebraically. We subtract 264 from both sides, leaving us with 120 on the left, 120 x's, excuse me. If we take 1584, we subtract off 264, we're left with 1320. Of course, our last step is to divide, in this case by 120s. So 1320 divided by 120 leaves us a x value of 11. Okay? And so what that implies is that if x was 11, all these ratios would work out. Now we should check that, and I'm going to check this right over here. We're going to check 18 over 5 times 11 plus 11. So 5 times 11 plus 11 is going to be 66. So 5 times 11 plus 11 is 66. And so really this is going to be 18 over 66. Now what we're really checking for here is if these ratios are the same. And we can do a quick value analysis. If I take 18 divided by 66, this is going to be equal to 0.27 repeating. We should check that against 24 divided by 88, this guy. And if we run that one, we also get 0.27 repeating. And so what that tells me is that the ratios of these side lengths are the same because they're both 0.27, or if you did it the other way, it's going to be a different value, 66 over 18. And so that means that value of x is good. And so the calculation for congruency is pretty straightforward. Just find the pieces, congruency is all equal, set them equal, you're golden. But for similarity, because the side lengths scale, we have to use a ratio in order to relate those side lengths. Okay? But good news, for similarity, the angles are still the same. So at least you got that, right? And so this is the end of part 3. I know this has been long, but like that's just the way it is for like new stuff. I don't know if I'd necessarily write a summary right now. I guess you probably could if you want to write like a one-page summary about how to like solve these, especially the part of the similarity. But you probably need more practice before you really know what you know and don't know yet. And so that's what you have next. If I haven't passed it out, I'm sure I'm about to. This is going to be classwork for now, homework if you're not finished, and be prepared to discuss it and be responsible for like the basics of this information next time you meet. Right? So that's it. Thank you for listening. Thank you for taking notes, and you guys have a wonderful rest of your day.